All right, in this video, we're going to be talking about transformations. So this is 1.5a, and there's two parts, obviously. There's an A and a B. This is A. Both deal with parent functions and transformations, but all right, the 6 parent functions you should know. Okay, the first one is just the good old linear function, and that is y equals x. Okay? And if you remember, y equals x line just looks like this, right? Straight through the origin, the parent function just looks like that. The next one that you probably learned is the quadratic, y equals x squared. Okay, that's a parabola. It sits right at the origin, looks like that, symmetric. The next one you probably learned was the absolute value graph. Okay, the way I remember this one is a v for value. It's a v right at the origin. It's not a parabola, it's not curved, but it's straight v. Then you probably learned the cubic function, y equals x cubed, and it kind of snakes through the origin, like that. The square root function is y equals the square root of x, and it starts at the origin like all of these do, but the square root function looks like you're diving off a diving board. And then last but not least is the reciprocal function. It looks like this. It's 1 over x. You may have learned it as the rational function. It's both. It goes by both names. All right, but the rational function looks like this. There are 2 L's. Okay. So the rational function like that does have 2 asymptotes that doesn't cross. All right, so hopefully you remember these 6 functions. You need to know them. You need to recognize them, know their names, know how to spell them, all that goodness. All right, now we're going to talk transformations of these functions. How can these guys be changed? All right. The first thing I want to talk about is 2 types of transformations, general categories. The first one is what we call a rigid transformation. And a rigid transformation means that it maintains the shape, okay? It can be moved left and right, up or down, or even be reflected, but it maintains its shape. All right, so that's the key thing. So it can be a horizontal shift, a vertical shift, and reflections. All of those can happen with a rigid transformation. All of those are considered rigid. They don't change the shape, they just move things left, right, up, down, or flipped. Now, the converse of that is a non-rigid. And what that does is it distorts the original shape. Okay, you know what distort means. It kind of messes with the shape. So what that can happen is a horizontal stretch or a horizontal shrink, and then the vertical stretch or shrink. Okay, horizontal, think like an accordion. Things can get pulled like an accordion both ways, right? Things that stretched left and right. Vertical, the stretch is up and down. Okay, now let's talk specifically rigid, vertical, and horizontal shifts on y equals f of x. Okay, f of x could be any of these shapes. Just don't get hung up on that. That could be any of those. So all these rules of thumb apply to any of these parent functions. So a vertical shift c units, now c is for constant, it can be any number that's added to the equation, okay? So now, if it is a vertical shift c units upward, it would look like this. It would be the original function, parent function, plus the value c. We know it's going up because there's a plus. Okay, that means up. Now, if it's downward, that would look like this. Minus c, right? That is going down. Now, notice if it's vertical, that plus c and minus c is outside the original function. If it's horizontal, c units to the right, now this is always going to go, if it's horizontal, it goes opposite logic. Okay, and so what I mean by that is this. Look, h of x equals. Now, if it's going to the right, you would think it's being positive, but it's really negative. So it would look like this, f of x minus c. And notice that the minus c is in the parentheses with the x. That's what makes it horizontal, okay? Outside the parentheses is vertical, inside is horizontal. So then number 4, a horizontal shift c units to the left, okay? Logic would tell you be going this direction, right? But, okay, so if it's going to the left, again, opposite logic, you're going to say h of x equals f. Okay, it's going to be plus c. If it's moving to the left, it is a plus sign, okay? Okay, again, notice the c is in the parentheses with x. That's how you know it's horizontal, not vertical. Now, reflections. Things can be reflected over the x-axis or the y-axis. All right, if it's reflected over the x-axis, then you will find a negative sign out on the outer edge of the function. So h of x would be negative, and then whatever the parent function is. Okay, the negative side is on the outside. If it's reflected across the y-axis, then it will look a little different, and it looks like this. The x value is negative. The original function's not, but just the x part is negative. All right? So these are the general rules of transformations that you need to know. You need to know what rigid means, what non-rigid means, how to decipher a vertical shift up, down, and a horizontal shift left, right, as well as the reflections over x and y axis. Now, let's keep going. Let's look at some example problems, and this will help us get started on the problems for the homework. The problem says, sketch the graph of each function on the same graph and describe the transformation as rigid or non-rigid. So I'm going to use different colors for each one, and you're welcome to use map pencils on your homework. So f of x equals x squared. That's a quadratic function, so it would look like this. Good old parabola, okay? Now, so this is f of x, so I would label that. Now, g of x, let's see, we'll do g of x in blue, do g of x in blue. All right, so we got to stop and think, what does that 3 out front do? Well, that 3 out front is a vertical stretch. Okay, that c value is greater than 1, right there. If that 3 was a fraction, it would be a shrink, but it's greater than 1, so it's a stretch. So it's going to take my original function, parent function, and stretch it up towards the y-axis. So it's doing this. All right, so the stretch, see how it started at the same place, but it took the 2 arms of the parabola and stretched them up closer to the y-axis. So this is g of x. H of x we'll do in green. So let's look at what's going on here. This plus 2 is going to move it left 2 units. The plus 1 is going to move it up 1 unit. Okay? So it's going to take my original point that was at 0, 0. It's going to move it left 2 and up 1. But it's the original shape. Okay? So we're going to take my original parabola shape and move it right here. Okay? So this is h of x. So you can see the 3 graphs. Black is the parent, blue is the vertical stretch, and h is the moving left and up. Okay? So we need to qualify these as rigid or non-rigid. Come back to this, okay? So if it's vertically stretching it, did it change our shape? Yes, so this would be a non-rigid transformation. On h, notice it kept the same original shape, it just moved left, right, and up. So this would be considered a rigid transformation. Okay, now we're going to try this again with number 2. Okay, so we're going to start with the parent function, y equals the square root of x, right? And that looks like, that's the diving board picture. Starts here, and it goes to the diving board picture, so it does this number. Okay, so there it is. Now, if we do g of x, let's do g of x in blue. It's 1/2 of x, so that 1/2 out front is a vertical change, but because it's less than 1, it's a fraction, right? Less than 1, this would become a vertical, because it's less than 1, we would call this a vertical shrink. Okay, this is a vertical shrink. Instead of pulling the graph towards the y-axis, it's going to pull it flatter towards the x-axis, okay? Same starting point here, but it's going to pull it down this way. So this is g of x. Okay, f of x in black, g of x in blue, and let's do h of x in red. So let's look at our equation. This negative out here is on the outside, so this is a reflection over x. The minus 4 means I'm going to move it right 4 units. Okay? So if I move it right 4 units, starting here, I count 1, 2, 3, 4. And instead of going up, I reflect it over the x-axis, and it's going to come down like this. Right? It maintains the original shape, however, it's just flipped over and moved over to the right. Okay? So now that we've looked at those, we need to label as rigid or non-rigid. So vertical shrink, so it kind of stretched our little arm over. So that would be a non-rigid transformation. It changed the shape slightly. This one that just reflected and moved it right did not change our shape. It just flipped it over. This is considered a rigid transformation. All right, in example 3, you're going to be asked to look at a graph and decide if this is the true equation right here. If this is the true equation, what's wrong with this graph? All right, so I would recommend, first of all, that you look at the equation. Decide what should it look like. Well, it's x plus 1 squared, so that's a quadratic shape. Okay, and the plus 1, remember, means it's going to move it left. That means it's going to move it left 1. Now, look at the graph here. They went 0, 1. They moved it to the right 1. Okay, because you would think it would go to the right 1 because it's a plus 1. But we also know that this change is happening to the x in the parentheses, so it's opposite logic. So it really should have been moved to the left. So it should be moved, graph should be moved left 1 unit instead of right. And that's what you'd have to tell me on when you describe the the error in the graphing. Okay? Hope that makes some sense, and we'll see you in class and work some problems.